Hi, I'm going to talk about the second lab, which is lines of charge. The purpose of this lab is to produce a computational model of two charge tapes exerting an electric force on each other. Also, we are going to estimate the amount of charge on each tape necessary to float one above the other. The fundamental physical principles used here is the law of superposition to add up the electrical field of each point charge. The diagram here is the observed model. The system is tape and the surrounding is everything else. The initial conditions are tape mass, tape length, tape width, tape charge, and electric force. The assumptions made are: first, there's no air resistance; second, each U-tape has the same charge; and the third, the charge of each U-tape is evenly distributed across the length. There are two main physics ideas. First is Coulomb's law, which states that the magnitude of the attractive or repulsive electrostatic force between 2 point charges is directly proportional to the product of the magnitudes of their charges, and inversely proportional to the square distance between them. The second one is gravitational force, which states that the gravitational force is directly proportional to the mass. For a brief preview of the result, gravitational force will be the same as the electrical force, which is 1.86 times 10 to the power of negative 3 Newton. Also, the charge of tape will be 1.18 times 10 to the power of negative 8 Coulomb. This is the main part of the coding in this lab. I first created constants, which are Coulomb's constant and gravitational acceleration. I set the initial values for the tape mass and tape charge. Then I created a function for the electric field and a line of charge so that I can visualize my code. This is the computational model as a result of the code. The magnitude of electric force is 2.1 times 10 to the power of negative 3 Newton. The magnitude of gravitational force is also 2.1 times 10 to the power of negative 3 Newton, and the charge for each one piece of tape is 2.92 times 10 to the power of negative 8 Coulomb. The errors involved here are: first, the assumptions made were not realistic. Also, this lab 2 was based on lab 1, which involved a lot of errors as the lab was conducted by hand. From now on, I'm going to answer what if and why questions. First, what if you had modeled each of your tapes as a single point charge like in the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with your line charge model. Tape charge using the point charge model was 2.28 times 10 to the power of negative 8 Coulomb, and the tape charge using line charge model was 2.92 times 10 to the power of negative 8 Coulomb. As you can see, there is a huge discrepancy in the values, considering that the numbers are small, and this is because calculations for charge and forces are different as different models were used. And why do these estimates differ? Which value is more likely to be closer to the real values and why? Line charge calculations should be more accurate because it has more steps, and the point charge is not realistic. So thank you for listening to the presentation, and this was Esther.